this video, we'll create an ancient Greek column generator using geometry nodes. We'll create full control over the amount of segments the column has, the height per segment, the overall width of the column, the pedestal type, and finally we'll add procedural edgeware using geometry nodes as well. So lots of stuff to learn in this video, so let's get started and let's get into it. Alright, so I've opened up this base file, which is available to download from the Patreon, by the way. It's free. Do that real quick. I'm assuming you just downloaded the base file so you can follow along nicely with this tutorial. So let's get started. You'll see several things. So we have a backdrop here. We have several pedestal types in their own collection over here. We have a light setup and we have a camera setup. And finally, we have a material ready to go. So let's take this into geometry nodes here and let's hide the main collection, the pedestal collection, and let's select the column collection. Now let's add in an object to create our geometry nodes system. So I'm going to hit Shift A, mesh, and add in a cube here. Now let's hit new. All right. So before we get started, I want to point out, please do enable the Node Wrangler add-on. So go to preferences, add-ons, look up the Node Wrangler add-on and make sure you have that enabled. It makes life easier. So please do so. Let's hit Control, right click and drag over this to sever the connection between the group input and the group output. So what we'll be doing is we'll be creating the Greek column. If we look at this image, you'll notice that it's made up of three main parts. So we have the Doric drum, which is the segment for the height, for the shaft, basically. We have a base and we have a capital. So this is what we'll create. So what we need is a shape which will work for the Doric drum. I'm going to start off by using a star shape. So let's add in a star node here and plug it into geometry output there. I think 8 points is a little bit too low, so I'm going to go for double that, so 16. Now we have three more options on our star node. The first one is the inner radius, which is a radius to control the inside, or the outer radius. And finally, we have twist. Now, we're not going to do anything with twist, so set it to 0 and just leave it alone. So I want a way to control both of these values using one value and still always be able to have the exact same distance between the inner and outer radius. Conveniently, we can create values by taking the group input node and clicking on an empty socket and then plugging that into a value such as the inner radius. So let's plug it into the inner radius and let's also plug it into the outer radius. If we now go over here to the right side to the modifiers tab, you'll see that we have a radius value which now controls the overall radius for both the inner and outer radius. Now, obviously, this doesn't work as intended because they are both the same, so it will always look like a circle, but we can easily change that using a math node, plugging it in between the output for the group input there and the inner radius value there. I'm just going to set this to be multiply. With this node set to multiply, let's set the value to be 0.8 and we will now always have the same distance. So if we scale this up, you'll notice that nothing's actually changing except the overall radius of our star object here. I'm going to set the radius to be 1.5 for now. Since this is a radius, the overall width is actually double that, since a diameter is actually 2 times the radius. So what I want to do is I want to actually divide this by 2. So I'm going to hold Shift and right click and drag over these two to combine these with a connector. Then duplicate this math node with Shift D, plug it in beforehand, set it to divide and set the value to 2. What you'll notice next about this shape, if we look at this image here, is that the insides of all of these are rounded off. So what we need to do is we need Blender to know that the insides of all of these should actually be rounded off like so. There's actually a surprisingly simple way of doing this within geometry node. Since this is a curve, as you can tell over here, we have a curve output. The curve is actually controllable with handles. So you might be thinking, handles, what do you mean? Let me just show you real quick. If I add in a curve object like this one and I tap into edit mode, you'll notice that these handles come with each of the points. So these handles can be exposed within geometry nodes and actually used. So what I'm going to do is I'm going to look up a node called the set handle type. There it is. Let's just plug it in between. Nothing's happened. Luckily, Blender always gives us tips. So we have this eye icon over here. And if you hover over it, it tells us that the input curves do not have Bezier type. So basically meaning our curve is not the right type. Blender has a fix for this, since there is this node called set spline type, which we can plug in between there. And the default spline type is a poly type, which is the one the star is using as well. But if we set this to Bezier, you'll notice immediately that something is happening. So we have the set handle type node here, and we could set it to left or to right. And by holding Shift, we can select both of them, making everything nice and round. The outside parts over here are also rounded off. And that's not something that we want because these need to be sharp. So luckily, the star node has this output called outer points, and we can just plug that into the selection for the set handle type, and this will convert some points to be sharp again. It's the wrong order, so in this case the inside ones are being sharpened instead of the outside ones, so we'll need a node to control that. As always, we can use a map range node for this. So let's just take a map range node and plug it in between. And instead from going from 0 to 1, we want this to go from 1 to 0. So let's set the 2 min to be 1 and the 2 max to be 0, and voila. This is exactly the shape that we want. If we now go into front view, you'll see that the shape is still just a curve. So there's no actual geometry to work with. So what we are going to do is we're going to take a curve line node, a curve to mesh node, and let's take the curve line and use that as the curve. Now, if we take the mesh output here and plug it into the geometry, we get a curve going up 1 meter in the Z direction. If we now take this set handle spline curve output and plug it into the profile curve, we get a nice profiled curve, which shows exactly the drum shape that we want. Now let's also enable fill caps, and we have a nice filled out drum segment. You might think, why do you have all of these nice crisp edges? That's because over here upright, I have this cavity option enabled, so yours might look like this, but enable the cavity option. All right, so this value over here, the Z value, is actually the segment height. And I want to control this from the modifier as well. So I'm going to take this group input node on the left side here, hit Shift D and duplicate it and move it over there. Now, since I only want to touch the Z axis, I'm going to use a combine XYZ node, then take this Z value and plug it into the group input to expose it, and take the vector and plug it into the end output here. Now we have something that we can control from the modifier, and it's very easy to set up. I'm going to set this to be 1.2. Set the overall width to be 1.2 as well. This does work, however, these names are strange and don't make any sense for our project. And especially if you send this to somebody else, they'll have no clue what this means. So I'm going to hit N within this geometry nodes workspace and then navigate to this group tab over here. Here we can select a value and change its name so it makes sense. So in this case, I'm going to say this should be the column width instead of the inner radius. And for this Z, I'm going to say, let's say this should be drum height. So one drum has a height of 1.2. So this makes sense now. Final step for this drum is that it needs to be tapered. So what do I mean by tapered? If we look at this image again, you'll notice that on the bottom down here, it's thicker than up top. So it's going up in a sort of cone shape, but a very, very mild cone shape, if you will. If we want to make a curve change its radius, we'll use the set curve radius node. Plug it in between the curve line and the curve to mesh node, and this will give us something to control the actual radius for the curve. I'm going to use a spline parameter node, which I've used a couple of times before, and we can use this length value over here, plug it into the radius, and this will effectively control the thickness of the curve over the length of it. So, and since it's using the starting point 0 and goes up to 1.2, that's what it's doing right now. So we need to invert this, and we'll use a map range for that. We have one down here, which already has the inverted value. So I'm just going to hit Shift D here and just move it over there and plug it in. All right, so that worked. It did invert the cone-like shape. So it does look the way we want it to. However, it's way too dramatic. So what I'm going to do is I'm going to take this 2 max value and just change this to be a very different number. So I'm going to go for 0.95, just giving us a very, very small taper towards the end. And since we'll use more of these segments going up, it will be tapering the more it's going up. So this looks perfect. 0.95 works fine. This kind of wraps up the entire drum element, the single drum element. So I'm going to go and add a frame just so I know which nodes belong together. Select all of our nodes here, hit G and just click inside of the frame, and it should automatically place them inside. And what we want to do next, if we just want to create an array of these going up, we can just take a mesh line. Let's take an instance on points node, plug the mesh line into the points, and take the instances and plug it into the geometry output. Now what we should have right now, especially if I disable this instance on points node, is a line going up 10 times. So the count of 10 for 1 meter. Perfect, because we want an instance of each of these. So let's re-enable our instance on points node, and let's plug in the curve to mesh nodes. So that works. It's just that these are still overlapping since the distance is not the right distance for the Z offset here. And we need a way to control the count. So what I'm going to do first of all is I'm going to take this combine XYZ value, which contains the drum height, and I'm going to plug this into the offset here. This will make sure that when we change the drum height, that all of these always align. So perfect. let's just plug that in there. Now, next, what we have is the count value over here. And we want a way to control this from the modifier as well. So as before, let's add in another group input node, place it over here, and let's take this count value and just plug it into a new socket on the group input. Now we have a control over on this side. I'm going to set it to 5, open up the menu with N in the geometry nodes here, and let's rename this to be segment count. All right, so what we want to do now is we want to make sure that these taper going up, and we can do this using this instance on points scale. If I now take an index node and plug that into the scale, what the instance node does is basically say, okay, everything needs to be from 0 to a certain number. In this case, the number is predetermined by the count value that we have over here. The index would start at a 0, which is true because we don't have any skill there. There should be 1 over here, 2, 3, 4, etc. going up. So this works, it's just not working completely as we want it to. Again, if we want to change these types of values, we'll always use a map range node. So let's add another map range, plug it in between, and we should have some control over this effect. Again, it started at 0, went to a higher number. We want to invert this. So to min should be 1 and to max should be 0. And you'll now notice that they're all gone. And this is because this from max only accounts for a 0 to 1 range right now. So the index might go from 0 to 5 in this case, but the from max is going from 0 to 1. So we need this value to always be the same as count. Luckily, we can just use this segment count over here and plug it into the from max. So we now have a segment count of 5 with a from max of 5, and we'll see that we also have 5 segments visible. We can change this from max value and change it to a number which makes sense so they are aligning. However, you'll also notice that gaps start to appear. The scale is changing, but it's changing the scale on all axes. So the X, Y, Z axes. We only want certain axes. And as always, we'll use a combine X, Y, Z node for that. Let's plug this in between. And let's make sure that the map range is only affecting the X and Y, but it's not affecting the Z. So the Z should always be the default value of 1. And voila. That works perfectly. We can change the segment height, still works, no gap. And all we need to change now is this to max value to line up all of these segments. So I'm just going to zoom in and then take this down until it's sort of aligned. It doesn't need to be perfect since this is an ancient man-made column. Let's frame these nodes as well. And with that done, the final step, what I want to do for this segment here is I want to move up the start location just so we can place the pedestal and the discs under it. So I'm going to go for 0.75 on the Z location there. As I showed you in the start of this video, we have this collection of pedestals already in the base file. So we have 3 over here, and we can actually use this within geometry nodes. So I'm going to disable the collection there again, but I'm going to also click and drag it inside of our geometry nodes system. Now, if I add a join geometry node and take this collection info and plug it in there, you'll see that they are now within our geometry node system. However, Blender treats a collection as a single object, so it does not know that these are all separate objects. So we need to enable both separate children, which will make sure that Blender knows that these are all separate objects, and reset children, which will make sure that they are all aligned origin point. If I now go into wireframe mode, you'll notice that they are all still there. So we need a way to select which one we'll use and also just show a single object. I'm going to disable this connection over here, and I'm going to add in a mesh line node. Now you might say, why a mesh line? Well, a mesh line, if I place this into the geometry output here, is the only way for us to actually get a single vertex. So if I set the count here to 1, doesn't even matter what distance this is, but if I set the count to 1, we will get 1 single vertex. If I now take an instance on points node and then plug in the collection info into the instance there, you'll see we get a single collection of all 3 of our objects. Luckily for us, the instance on points node allows us to do something cool, which is enable this pick instance. Now it will use only one of these 3 objects inside our collection. And if we add more, so we might 5 or 10, it will still just select one of them. We also have this instance index value. If I click and drag and then type in group input, this will add a group input node with a new exposed value, which is a selector now for which object to use. So that's exactly what we want. We can now just tweak which pedestal our column should use within the modifier as well. Again, if we now plug it into the join geometry node and combine the 2 together, this is perfect. As before though, the name is not very convenient. So I'm just gonna hit N here, open up this menu and change the name to be something like pedestal type. All right, so we have the pedestal done and we have the shaft done. And you'll notice that we don't have a capital yet, and we still need to fill this gap using a shape here. Let's fill up this gap first of all. I'm going to use a cylinder for this. So let's take a cylinder here and let's plug that into the geometry output. So we just only see the cylinder for now. I'm going to set the depth for the cylinder to be 0.2. So it's a nice small disk. And I'm going to add in a subdivision surface because I want to round off the edges for the cylinder. Now let's plug that in between, set the level to 2, and you should see it's starting to be rounded off slightly. However, it's not looking very good, and that's because we don't have enough geometry. So if I go into the wireframe here and disable or mute with M the subdivision surface, this is the way our cylinder looks. I want more side segments, so I'm going to hit one more here. So it's 2 now, and we have an actual sort of loop cut in between here now. And I want fill segments as well to fill in the top. So I'm going to set this to 5. And if I now re-enable the subdivision surface and go back into solid view, you'll see we have a nicely smoothed out disk shape here now. I'm going to re-enable the column here, plug this into the join geometry node here as well. And our disk is in here, and we just need to move it up and make it so that it actually scales. So if we now change the column width, you'll notice 2 things. First of all, our base is not scaling along with it. And second of all, our disk isn't scaling either. So we can use the column width again to actually make sure that all of these scale along with it. We have the group input here, and if I hit Control H, it will expose or hide. So you can hide or expose all of the values that are in the group input here. This also works for different nodes, by the way. So if I do it over here, you'll see it just hides several parts. So I'm going to use this column width here, and I'm going to take a combine XYZ node and plug that into the scale. Now I want to change the scale for the X and Y again, but leave the Z alone because I want the height to be the same always. So this means that now if I go into solid view and I change this, you'll see that this actually changes the way our pedestal is looking. It's making it bigger or smaller depending on the overall column width. So that's nice. Now we can do something similar for the cylinder over here. So just take another group input node, take the column width and plug that into the radius. This should now effectively scale up the radius for our cylinder to always match the width of our column, like so. It might be a bit too big, but we'll see that in just a bit. Now we need to move this up, and we can actually do this using a transform node. Super easy, of course. So just plug it in there, change the Z translation until we match it up. And this should just be eyeballing, doesn't need to be perfect. I think 0.5 seems to work. Yeah, 0.5 is fine. So we have it over there. And you'll also notice that the radius might be a bit too big for now. So what I'm going to do is I'm going to take this scale value here and leave the Z at 1. As always, don't touch the height of any of it and just change the X and Y and set it to 0.9 or so. All right, so our disk is looking fine. We just need one more disk, and obviously that's a very, very easy thing to do. We can just take another join geometry node, plug that in between, take another transform node, and let's take our geometry output from the first transform node, plug it into the new transform node, and take this and plug it into the join geometry here. You'll notice it's exactly within the other disk that we have. The scale is already changing, so that's a good thing. And I'm just going to make it so that this goes up, align it again. Now I do want to change the Z for this one. So I'm going to go 0.9 on this one as well. And actually I'm going to set all of these and set them to 0.75. Now let's realign our object here, and 0.3 seems to work perfectly. Everything is aligned perfectly and the sizes are also working. And still, if we change the column width, everything is scaling along as intended. All right, so we now have the entire base for our Greek column done. I'm just going to frame some of these so we know which ones belong together. Just for clarity's sake, I am going to combine the pedestal instance on points into this final join geometry node before plugging it into this absolute final join geometry node. And we just need to create one more object, and that's actually capital, which is just an inverted version of what we already have here. So super simple here. What I'm going to do is I'm going to take another transform node, then take the join geometry that we have over here, which is the base, and then plug that into the transform node. Now I'm going to take the transform and plug it into the join geometry at the end there, and we should get an exact copy again within here. So we can actually rotate it on the X 180, so it's an inverted version, and we can now just change this Z location and move it up and align it. I'm going to leave it at this value for now, just to show you why this isn't just working just yet. If I now change the count, for example, and I change the drum height, you'll notice that this thing is not moving. So it's not respecting the actual distance that we have in between base and capital. So we need a procedural way of doing this. Again, we can change this value and we can use the group input to actually define the distance here. Let's add in combine XYZ since we're only changing Z over here. So change this Z, you'll notice that it's actually moving up or down. We have several values here that we can use. First of all, we have the drum height, and then we have the segment count. Now, the overall height of the base is always drum height times the segment count. So we can just multiply it. If we take a math multiply node, we take this value and plug it into the Z, it will always multiply the drum height times 0.5 in this case, but instead of using 0.5, I'm going to multiply it times the segment count. Now this works perfectly. However, this is not respecting the offset that we have for our mesh line here. So I'm just going to add in another math node, duplicate the multiply node here with Shift D, plug it in between, set it to add, and we now just need to add in a value which works. So 1.5 works perfectly if we respect the size or the scale of the base here. But what you'll notice if we look at this image is that the capital here is usually a little bit smaller and thinner than the actual base. What we'll do instead is actually, first of all, change this scale. I'm going to set this to be 0.75 here. That works perfectly. And we now just need to change this value to match up again. So I'm going to go into wireframe mode, zoom in a little bit, and let's just align these, see what works. 1.31 works in this case. All right, so we now have one perfect looking column, and we still have all the control. So we have the column width, we can change that. We can change the drum height for the overall height of each individual drum. We can change the amount of segments our column has. And finally, we can change the pedestal type. Now let's re-enable some of the collections like the base collection, and let's go into camera view with numpad 0 and hit Z and go into a rendered view. This is our column now, and the scene looks nice. However, you don't see any materials, it's all just plain white. And what you'll also notice is if we go up here, you'll see that we have some flat shade. So let's fix some of that. Let's hit a set shade smooth node and plug it in between. And second of all, let's take a set material node and then click over here and select the procedural limestone to be the material. So the material is already set up with ambient occlusion and all those good things. I have it enabled in this base file as well, so it should work perfectly for your scene. So it now looks like an ancient Greek column. However, it doesn't really look that ancient because it's still all perfect. You know, you can hardly see the edges between the Doric drum columns. You don't see any edge wear, and we want this to look a little bit ancient. So what we can do is we can create procedural edge wear. So to create the edge wear, what we want to do is we want to create some sort of displacement without doing it within our materials. So we can use geometry nodes for this. And as always, if we want to display stuff, we'll use a set position node. And we can now change stuff using this offset value. Now, if I take a noise texture and I plug that into the offset, you'll notice that stuff is actually happening. It's also doing some weird stuff, and I'll show you why that is. It's sort of translating each of these objects individually. If I take the random value and plug it into the surface, you'll notice that Blender treats each of these objects as individual objects, even though they are within the same geometry nodes system. And if we now go to geometry nodes and we actually add in a realized instances node behind the set material node, you'll notice that it starts working. Blender now sees this entire column as one single object, and that's exactly what we need for this to work. So it's being offset in every direction, and usually what I say is, okay, then we'll use a combine XYZ node, but in this case we won't. We'll use a vector math node, and instead of setting it to subtract, which is the normal way of getting all of this to move back to its original position, just add a subtract node with 0.5. I'm going to set it to multiply, and I'm going to take this and plug it into the bottom value here, and I'm going to add in a normal node, which will look at the normals for this object. And we're going to multiply the normal times noise texture. So what it does now is it will look at the normal direction, which will always be a direction going in a sensible fashion outwards like this. And it will multiply it by the noise texture. Now the effect is way too strong. So I'm going to control this with a math node set to power. And I think a power of 7 should work just fine. And you'll notice that we now get some nice sort of wear and tear on this object. However, it's going outward, which doesn't make sense. Usually stuff crumbles down and caves inward, so not outward, obviously. And we just need to tell Blender that all of this needs to be inverted. So with the vector math multiply node, let's hit Shift D, place it beyond it, and then multiply it by a value of -1, so all the damage actually goes inward. It's still a little bit wonky, and that's because our noise texture is not very detailed. So I'm gonna go and set the detail to 10 and the roughness to 1. And what we have now is some perfect edge wear going on over here. And look at that. I mean, all of the Doric column drum stuff is now separated from each other. We get nice edges, get nice weathering as well. We can still control the amount of edge wear that we have by using this exponent value over here. Again, you might want to change the direction it's going, but for now, if you just use 7 or maybe 6.5, it looks almost perfectly all right. So that wraps up this entire column generator. Again, to summarize it, we have a star shape that we are extruding using a curve line and set to curve radius curve to mesh node. We are tapering the object using a map range here. We are creating nice rounded edges on the inside of these star shapes using the set handle type. We are then creating an array of all of these drum segments using a mesh line, an instant points node, and an index map range to actually make sure it tapers nicely towards the end. Then we have a combination of both a pedestal and 2 cylinder discs to create our base, and an inversion of that to actually create our capital, so the top part of our column here. And finally, what we do is we shade it smooth, we give it a material, and we realize the instance, so we have one single object. Now we can take this object, give it a set position, and change the normal vector position with a noise texture to generate some type of edge wear. All of these features are now exposed within our modifier over here, so we can just change the overall width, we can change the drum height, change the amount of segments. All of this fully procedural for you to generate an unlimited amount of ancient Greek columns. All right, so I hope you enjoyed this video. It's a bit longer than you might be used from me. I wanted to pack it as full of information as possible. So I hope you learned a lot of techniques with this video, and I hope you enjoyed it, of course. So as stated in the beginning of this video, the project file, the base file in this case for this video, is available on the Patreon for free, but you can also get the complete project file by joining the Patreon. This comes with over 40 other project files and assets, so lots of stuff to get there. I want to thank you for watching and see you in the next one. This video was made possible by the following patrons. Thanks so much for your support.